Question 7. This question is taken from Cambridge IGCSE Additional Mathematics, June 2003, Paper 2, Question 6. Find the solutions set of the quadratic inequality. A. X squared minus 8x plus 12 is greater than 0. To solve this inequality, we need to factorize the quadratic expression. X squared is x and x. 12 can be 1 and 12, 2 and 6, or 3 and 4. We need to get a minus 8x. Hence, we will choose this combination. We put a 2 here and a 6 here. To get a minus 8, minus 6, minus 2. And lastly, we need to check negative and negative, we get a positive. When x minus 2, x minus 6 is equal to 0, x minus 2 is equal to 0, x is equal to 2, or x minus 6 is equal to 0, x is equal to 6. We will use graph sketching method to solve for this inequality. First, draw the axis. Our a value is 1, which is greater than 0, hence this curve is a smiling curve. And it cuts through the x-axis at 2 and 6. We are looking at the area which is greater than 0, which means above the x-axis. Hence, the range of values of x is less than 2, x is greater than 6. B. X squared minus 8x is less than 0. Similar to what we did for A, we need to factorize the quadratic inequality. We factorize the x out, leaving the x minus 8 inside the bracket, and the expression is less than 0. When x bracket x minus 8 is equal to 0, x is equal to 0 or x minus 8 is equal to 0. For x minus 8 is equal to 0, x is equal to 8. We draw the x-axis. Our a is equal to 1, which is greater than 0. Hence, it is a smiling curve. And the curve cut through the x-axis at 0 and 8. We are looking for the area which is lesser than 0, which means the area below the x-axis. Therefore, the solution for this quadratic inequality is x is between 0 and 8. Hence, find the solution set of the inequality modulus x squared minus 8x plus 6 is lesser than 6. We have the inequality modulus x squared minus 8x plus 6 is less than 6. Recall back what we have learned in modulus quadratic inequality. For modulus quadratic inequality, we will have two cases. The first one, x squared minus 8x plus 6 is less than 6. And the second one, negative bracket x squared minus 8x plus 6 is less than 6. Let's solve for the first case. First, we bring all the terms to one side. X squared minus 8x plus 6 minus 6 is less than 0. Simplify the inequality. X squared minus 8x is less than 0. If you notice, this is exactly the same as part B. Hence, the solution is x is between 0 and 8. Now, let's do the second case. First, we divide both sides with a negative 1. We get x squared minus 8x plus 6 is greater than negative 6. Then, we bring all the terms to one side. X squared minus 8x plus 6 plus 6 is greater than 0. Simplify the inequality. X squared minus 8x plus 12 is greater than 0. And this quadratic inequality is the same as the quadratic inequality in part A. Therefore, our solution is x is less than 2, x is greater than 6. These two sets of answers come from the same modulus quadratic inequality. Hence, we need to combine all the solutions to obtain a final solution. Since we have three inequalities, I will choose to use number line to solve it. This is the x-axis, 0, 2, 6, and also 8. For the first inequality, x is between 0 and 8. For the second one, x is less than 2. And the last inequality, x is greater than 6. We need to find the area where the inequalities overlap. Therefore, our final solution will be x is between 0 and 2, and also x is between 6 and 8. Question 8. This question is taken from Cambridge IGCSE Additional Mathematics, June 2013, Paper 2, Question 8. The line y equals to 2x minus 8 cuts the curve 2x squared plus y squared minus 5xy plus 32 equal to 0 at the points A and B. Find the length of the line AB. Before we solve for this question, let's sketch it to have an idea how it looks like. We have a straight line and a curve, so probably it looks like this. And they intersect at point A and point B. We need to find the length of the line AB. The first information we have is y is equal to 2x minus 8. We let it be equation 1. And the second piece of information we have is 2x squared plus y squared minus 5xy plus 32 is equal to 0. We let it be equation 2. Recall back what we have learned in 2.2 roots of quadratic equation. We need to solve these two simultaneous equations to obtain the intersection points. We will use substitution method to solve for this question. Substitute equation 1 into equation 2. 2x squared plus 2x minus 8 squared minus 5x. 2x minus 8 plus 32 is equal to 0. We need to expand this bracket and also this bracket. 2x squared plus 4x squared minus 32x plus 64 minus 10x squared plus 40x plus 32 is equal to 0. Then we need to expand this bracket. 2x squared plus 4x squared minus 32x plus 64 minus 10x squared plus 40x plus 32 is equal to 0. We simplify the equation. 2x squared plus 4x squared minus 10x squared. We will get minus 4x squared. Minus 32x plus 40x, we get plus 8x. And lastly, the constant, plus 64 plus 32, we get plus 96. And the whole equation is equal to 0. We divide the equation by -4 to further simplify it. x squared minus 2x minus 24 is equal to 0. Let's factorize the quadratic equation. X squared is x and x. 24 can be 1 and 24, 2 and 12, 3 and 8, or 4 and 6. We need to get a minus 2x. Hence, we will choose this combination. 4 and 6. To get a minus 2, we minus 6 plus 4. And we check plus and minus, we will get a minus. Hence, x plus 4 is equal to 0, or x minus 6 is equal to 0. For x plus 4 is equal to 0, x is equal to negative 4. For x minus 6 is equal to 0, x is equal to 6. After we find the x values, we need to find the y values as well. Substitute x is equal to negative 4 into either equation. Here, equation 1 is easier. Hence, y is equal to 2 multiplied with negative 4 minus 8, which is equal to negative 8 minus 8, and we will get negative 16. The first coordinate is negative 4, negative 16. For the second y value, substitute x is equal to 6 into equation 1 as well. Y is equal to 2 multiplied with 6 minus 8, which is equal to 12 minus 8, that is 4. The second coordinate will be 6, 4. We need to find the length of the line AB, meaning we are finding the distance between the point A and B. Recall back the formula to find distance. Distance is equal to x2 minus x1 square plus y2 minus y1 square and square root the whole thing. Let's substitute all the values into the formula. The length AB is equal to 6 minus negative 4, the whole thing square, plus 4 minus negative 16, the whole thing square, and then square root them. We get 6 plus 4 square, add with 4 plus 16 square, square root, which is equal to 10 square plus 20 square, square root, 100 plus 400, square root, that is square root 500. We can further simplify it. Square root 500 is square root 5 multiplied with square root 100. Square root of 100 will give us positive 10 and negative 10. Since this question is asking for distance, we can ignore the negative value. Therefore, our final answer is 10 square root 5 units. Question 9. This question is taken from Cambridge IGCSE Additional Mathematics, November 2011, Paper 2, Question 2. Given that the straight line y equals to 3x plus c is tangent to the curve y is equal to x squared plus 9x plus k. Express k in terms of c. First, let's have some idea how it looks like. We have a curve and a straight line that is tangent to the curve. The straight line is y is equal to 3x plus c, and the curve is y is equal to x squared plus 9x plus k. Similar to question 8, we need to solve for these simultaneous equations. We let the straight line equation be equation 1 and the curve equation be equation 2. Equation 1 is equal to equation 2. 3x plus c is equal to x squared plus 9x plus k. We rearrange the equation. To get a positive x squared, I'm going to move all the terms from the left side to the right side. Therefore, we get x squared plus 9x minus 3x plus k minus c is equal to 0. Simplify the equation. X squared plus 6x plus k minus c is equal to 0. For this equation, our a is equal to 1, b is equal to 6, and c is equal to k minus c. Tangent to the curve indicates that it has only one solution. Therefore, the discriminant is equal to 0. b squared minus 4ac is equal to 0. We substitute the values of a, b, and c into this equation. 6 squared minus 4 times 1 times k minus c is equal to 0. Simplify the equation. 36 minus 4k plus 4c is equal to 0. We divide the whole equation by 4. 9 minus k plus c is equal to 0. We are asked to express k in terms of c, meaning we need to make k our subject. Hence, we need to separate the k from the other terms. K is equal to 9 plus c. So that's the end for this chapter, Quadratic. In the next video, we'll begin a new chapter. So see you in the next video.